So let's relook at section formula with the help of vectors. Now, we have a line PQ, and this is our reference point O, and we have a point R, which is dividing this particular line in the ratio of m is to n. M is to n, right? So let's name all of this first. So this we'll call it as A, this we'll call it as B, and this we'll call it as R. Now, what we are trying to do here is we are trying to get an expression for OR, that is vector R, with the help of M, N, A, and B. Okay, that's the agenda. We are going to express vector R with the help of A, B, M, and N. Okay, so that's the whole agenda. The first thing is we'll start off with writing that P R by R Q is vectors. The length will be in the ratio of m is to n. That's the whole funda of the point R dividing the line PQ, in this case vector PQ, in the ratio of m is to n. Right? That's the basic idea. Now, I need to re-express this two expression, and we're pretty much done. So if I take this as the tail, which it is, and this is the head, and if we consider this particular picture, okay, let me do this. We will need it. Yeah, if you think of this picture, right? Just think of this. What can I tell you about PR, vector PR? Well, if I move from O to P and P to R, as per triangle of vector addition, it should be equal to R. So let's write that. R is equal to vector A plus PR vector. Agree? So I can rearrange this as PR is equal to R minus vector A. This is from figure. Now, next thing is the other figure. So again, we need to express RQ in terms of all of this and so on and so forth. So let's look at it. We have OR, then RQ leading up to vector B. So vector B is equal to vector R plus QR, right? If I rearrange this, therefore QR is equal to vector B minus vector R. Now, if I substitute above two equations to 1, actually, sorry, this I should call it as 1. So substituting in 1, what do we end up with? We have R minus A divided by P minus R. Can you see that? It's very simple. M by N. So if I simplify this, I don't have much space, so I'll do it off here. So vector R, if I simplify this, you will end up with MB plus NA. This is same as what we have studied before. The same formula actually. Divided by M plus N. Right? This is what we studied, if you guys remember. But in vector form. So this is our case wherein we have the R internally, dividing internally. The same funda goes with something called as external. External means what? So this is our vector PQ, and that's our point R. If I extend PQ point R, right? So this particular line or position vector is showing point R. So this particular point R is dividing PQ externally in the ratio of M is to N. So how will we go about doing that? So this is M. This is M. And this would be N. This would be M. Okay. So think of it, take a second. So which is our main vector? Think of where is the external point and how is the ratios? How are the ratios? The funda is the same actually. So we'll call this as A, this as P, and that would be our R. So here too we have PR by QR is equal to M by N. So now we're getting expression for each of them. So PR, right? PR, we have to take the entire big triangle. So basically we have OP to PR is equal to vector R. That is vector A plus PR, vector A plus vector PR is equal to our vector R. So if I rearrange this, so vector R will be equal to, this would be, oh, vector R is, okay, sorry, we need vector PR actually. Vector PR is equal to vector R minus vector A. Next is the other small triangle. So here vector B plus QR, right, is equal to vector R. Again, understand the naming convention. We always start with the tail and move on to the head. So PR is equal to vector R minus vector B. And finally, we'll substitute in say 1 over here too. So sub n1. So what are we looking at? These are vectors. So this would be vector R minus vector A divided by vector R minus vector B is equal to M by N. So this would not result in the same as what we got in the last expression. So this would be a different result. So this would be R into N minus A into N is equal to R into M minus B into M. So if I rearrange this, we can see the answer. Vector R is equal to, if I transpose this and so on and so forth. So that would be vector A into N minus vector B into M, right? Divided by, so I'm transposing this N minus M. This is one of the expressions, one possibility. Okay, guys. So that would be our answer, right? You can pause and have a look.